Good afternoon, everyone. Welcome to the interactive session about Databricks jobs and debugging best practices. This is more of an advanced feature topic that we wanted to share with you and help you work through some of these topics. My name is Lalit Nukla. I'm a member of the user services team on the QDAS project. So in today's session, we are going to work through two main problems. Uh, the material that you will use to work through these problems have been covered by my teammates on the user services team, and they have been linked here. There's one about breaking large processes into tasks, and there's the other one about debugging in the code design itself. How would you do that? If time permits, we will also go through a bonus question where you will see how once you have debugged your code, once you have put your code into task, how can you use a job helpers package that we put together to run these jobs programmatically? Uh, Points to keep in mind when you're working through this is always think about your code as not a monolithic piece which you have written, but try to break it down so that each cell does a unit of work and then a bunch of cells together does one task. If you're doing something completely different than what you originally intended to, move it into a different notebook so that it's all broken down and set up so that it's easy to trace through the work. Next, keep in the same vein, keep the cell codes short enough so that it's easy to troubleshoot rather than scrolling up and down and not knowing what's going on. These are like basic things that once you start doing it, it becomes a lot more obvious. Then there is orchestration patterns for the task that you need to keep in mind and understand how to do it. The cluster sizes for tasks, that's important to understand. You don't want to use enormous clusters to do a small task, and at the same time, if it's a big task that you are trying to do, make sure that you're not doing it on a smaller cluster where the task might fail. Then, if there are any variables that are being used throughout different notebooks that you have, different tasks that you have established, or these variables change over time because you're trying to run a monthly report or something, how to move this into global variables for the job so that you change it at one place and then the job will still run without you modifying your notebooks or anything. So those are the things that we're trying to address here. Now, how you go about doing it is I set up two scenarios. The first scenario is that it's a long running PySpark notebook that should actually become a job and with multiple tasks. As users, when you're working through this, I want you to think about what the logical stages should be, where the notebook boundaries are. And what I mean by that is that, okay, there's, small code of work, small scope of work being done in a notebook, and then move on to a next scope of work in a different notebook. Thinking about the input and output contracts, what goes in, what comes out. Then whatever comes out, do you want to process that into intermediate tables? Then when you do all of that, how does this notebooks can be turned into jobs with multiple tasks? Some run in parallel, some run sequentially. Um, those are the things that you will work on in the first one. I just want to make it very clear. There's a lot of work to be done in scenario one. So what we are expecting is the user should be able to set up the job, execute it. It may not be able to finish by the time we are done with this session, but if you can get to it to a point where the tasks have been set up, you're able to click run on the job. We are 90% there. Um, the scenario that I've created here for this one, and you can actually look at it in the notebook here that is set up, is to build a diabetes utilization cohort and a monthly summary for your consumers. Now, this basically is one that has to be run every month or every quarter, whatever could be the scenario. So it automatically, you should start thinking about it. Okay, I need to set this as a job. So how would you do it? In this one, the instructions are here. There are 4 to 6 logical steps that you will identify out of this one. Put them in separate notebooks. Define what your dependency order should look like for each of this. So notebook 1 completes, notebook 2 runs, notebook 3 runs after notebook 2, so on and so forth. decide what the tasks will write out, and then implement it in a job flow task. To make it a little more easy to get along with this, I've suggested what the splits should look like. It's just one way of doing it. If you guys can come up with a different way of doing it, that's fine as well. I created a structure of what that pipeline should look like. There are again, as I said, there are different ways to doing this. This is just one way of doing it. So this is where you have to start thinking about what your architecture is going to look like. And that's why I said that this is going to be an advanced topic. This is a clean running notebook. It will run. So there's all you have to do is make your logical splits and make sure that you select the right target DB where your tables need to be written. Where this is basically where you will have your permissions to write. And then create those notebooks, put it in task. You don't have to change the code at all. It will run. That's scenario one. Going back to scenario two. Okay. Sorry about that. The next one we are going to look at is scenario two. This is going to be in another breakout room. Here you'll be given a long-running single cell notebook. All the code is in one notebook. All you have to do is there have been errors introduced which you won't be able to see because of the way the Spark does its lazy execution. The goal at this point of time becomes to break out the code into its individual cells and then have print statements, display statements, force an action on your transformations, on the joints, so that you can see what the results are looking like at that intermediate step, identify any errors, fix it, and run it again. The thing to remember is this is how real development is done. You work through single pieces of code, you run this on your all-purpose compute, figure out what is going on, put excessive display statements, print statements to see what's going on. And once this is ready, then you basically move it into production jobs and stuff like that, where you remove those display statements, but now you know that your code is going to run because you have gone through the process of debugging it. So the scenario two also has a notebook. Again, this is how you'll want to break it into cells. I've just given another high-level overview of what needs to be done. This code will fail. You won't see the results failure, obviously, because it will run and give you erroneous results, honestly. That's basically how this has been set up. But the results are wrong, so you'll need to debug it. To debug it, you have to break it into cells and make sure you go step by step. That's basically what we are asking the users to get into the mindset of. If for this one, at the end, you'll have a successful execution and have the results validated, and that should finish this exercise. There's a bonus. I don't think we will be able to get to it because these two are going to take almost all of the time necessary to work through it. But the whole idea with the bonus 3 is that it's a job helpers package. If you have the first two things, if we have done it correctly, you have a programmatic execution package, a job helpers package that can actually take your successfully executed notebooks or the tasks that have been set up and run it, put an HTML output for you. In order to work through that, I have a couple of other notebooks, but we'll get to it when we are ready. So that's it. If you have any questions, please let me know, or else we can go to the breakout rooms.
Okay, great. Let me go ahead and open up the rooms. There should be 3 rooms available to you, 1 for scenario 1, 2 for scenario 2, and then the bonus. Lilith did put the notebook in the chat, but if you're not seeing it, I can drop the link again. And we will meet again in perhaps 30 or 40 minutes.
40 minutes.
I'll make sure. Okay, 40 minutes. I'll make sure to put reminders.
Yeah. Thank you, Lou. Let's start with this. How did it feel? When you guys put this together, I'm hoping that So the stuff that you saw was that for scenario one, when you put them in tasks, it is broken down into nice notebooks, so you know what the code is. It helps you uh, set up your jobs and how to run it, what the task boundaries should look like. And you're able to decide, okay, what should I store as temp tables, which can be reused later. Again, if some tasks might fail because they're long running or you don't have the configuration set up correctly. So which would benefit from retries. You don't want to rerun the entire notebook, but only one task specifically. So it helps you to isolate any issues that you are having, or if you have to rerun something, you can rerun it. So this helps in production. How would you want to set it? Plus, reusability of it. You can change the parameters and be able to run it. As an example, let me show you what I did. This is how I had my tasks set up, loading and cleaning the databases, building the evidence, building the cohorts, running based on the cohort, it can run these two parallelly, 5 and 6, and then the gold and the silver tables, which we call, that's just the way to name it, but it's the final tables, output tables that can be reused in dashboards or report generations. So when you set these things up, you're basically setting it up as a path. You choose your compute clusters. You can actually be very cognizant about it and be smart about it in choosing the right cluster. You don't want to have really large, powerful compute clusters to run a small task, but at the same time, a small clusters to run huge tasks. So you can pick and choose. That helps it to be more efficient in running this job. You can set what it depends on. I want this to run only after these two have succeeded. If these don't succeed, this won't run, which means it stops. You don't get erroneous results. There's a breakpoint if things fail. Job parameters. This is the one that I was talking about. You can actually edit these parameters. I have adult age set at 18. Maybe your analysis wants, okay, I don't care about people who are less than 21. So you can just go in here, change this to 21, and run this entire thing without going into each and individual notebook and trying to change it, which can actually increase it could be an error in changing it. And also start and end. This is set up like this. Let's say you want to run it a year later. You can just change it here and then run it again. Like change it to 2016 to 2021, and you can run it. So there are multiple advantages of setting up a job. I have 2 runs here for this one, and this is one thing that we really wanted to talk to you. One of them runs on XFlash machines, and the other one actually ran on just a large machine, on a lower compute, just a large. So it has just about 8 gigs of memory. This actually helps you to kind of see that there's not a huge difference by going to a bigger compute. From 11 minutes that it took on what we call as the large system to an X large system, it was not just 9 minutes. It will help you control the operational expenses. If you break it down into tasks, and if you know what is the right size of clusters, and you target each of this job to the right size cluster, you'll run your job efficiently, and it's not going to just explode the compute costs. So that's with job 1. Job 2, and this would be my, I'll go quick through this one. Scenario 2. Because of the long running job, what I'm expecting that it would have seemed that it ran correctly, but there was a lot of errors, either because a cast might have failed. The way it was set up is that there's something wrong upstream with the conditions, and it did not convert the diabetes codes for all of them to a proper integer. So now when you try to run the risk analysis on the conditions, because of the lack of conversion, it will actually fail for you. So you would have to do something like this where you have to convert it. Give me a second. Readmission features were done, condition features. Because there was strings and integers all mixed up because the earlier pipeline would have failed maybe, and you did not realize that. You have to cast it into a big int, but if it's all digits, that's when it will work, or else it fails saying that, oh, I can't cast it because there is a type issue. You will find this out immediately here rather than going all the way through setting up the joins and all of this running throughout and then not realizing that you got wrong data sitting out there. So that's why during the development process, we want to start putting in as many print statements, display statements to see, all right, how much counts am I getting? Am I getting distinct counts? The other one where we actually had in the wrong code was a wrong join, which actually exploded the joins. So the member counts and the distinct member counts should match up. But what you would see if you could look here, sorry, in scenario 2's notebook, the counts would have exploded dramatically because one of the joins were wrong. Again, if you do not break it, run your print statements, counts, displays, you will not know it until the very end. And sometimes you write these results out into a report or into a table and not realize until somebody else is looking at it. So it becomes very crucial for during the development process that you break out your code into as small pieces as possible and look at the results as you go through with all your print statements, display, force Sparks, lazy execution to run. When do you want to run it and how often do you want to run it? Again, that also becomes, the more you practice, the more you'll know where the chances of it failing is going to be. Depends on the data, depends on the size of complexity of the transformations and all of that. So again, as I said, this is an advanced feature. There's a lot of pros and cons on how to do it. This is something, but once you start forcing yourself to think through it, it will get better. Last but not least, I also made a mistake here. That is, once I put the answer key, but I did not put any comments in. One thing that I cannot stress enough is that when you're doing your development, try to write what your logic in plain English as comments up here. That will actually help debugging it easy. When you're pair programming with anyone, they'll realize what we are doing, and it will help your development time go faster. That is all I had. I'm sorry, I ran a little bit over.